All right, hi everyone. I'm Rick Carragher. I lead smart home technology. Along with my colleague Mark, we're going to talk to you about how you can connect any device to Alexa. Specifically focusing on smart home today. And smart home has been around for a long time. There's been enthusiasts for probably 20 or more years who've enabled automation in their house, lights turning on automatically, or maybe even the lawn sprinklers. But it's only with the voice technology and the ability to control your smart home with your voice that we've really seen broad adoption of smart home, and Alexa's been obviously the big player there. It's a pretty natural experience, and it's an eye-opener when you come in with an armful of groceries and you say, Alexa, turn on the lights, and you don't have to fumble with switches or whatever. So Alexa and smart home have been together now for 3 or 4 years, and we've controlled a certain number of devices, lights, plugs, thermostats, locks, and things like that. We're really excited to see what developers are going to do and build next, and we want to be able to enable them to control any of those devices with voice as well. So today, we're going to talk to you about how devices connect to Alexa today. How do those lights get controlled through voice? We're then going to talk about some new APIs that we're launching and some new voice models that we believe will enable you developers to model any device and enable that device to have natural voice control as well as participate in routines. Then Mark will come up and he'll take you through a really interesting demo on how you can use these new APIs and build a device that we probably would never support as a first-class device. So a brief overview of how Alexa works today in controlling smart home. So let's say that you have a Philips light bulb in your living room, and you say, Alexa, turn on the living room lights. That utterance gets passed to the Alexa cloud. The Alexa cloud does, of course, the automated speech recognition and natural understanding to understand that what the customer is trying to do is turn on the living room lights. That turns into a turn-on intent that gets passed to the code and services that my team operates. We look in our records for that particular customer, find the device that's associated with the name living room, as well as find out the manufacturer that the device is owned by. And using that information, we can route a API request to a Lambda that we said it's Philips, so a Lambda that Philips operates. That Lambda then receives a control directive from Alexa and then will proxy that into their cloud, which will then in turn reach into the house of the customer and turn the living room lights on. And this directive-based simple APIs is the way that all smart home control works today. I do want to point out that in the top of the picture here, you see asynchronous responses, proactive state updates. So there are cases where the customer is using either a physical switch or a companion app, maybe the Philips companion app, to control their lights. Alexa wants to know about those state changes too, so we can deliver the most natural experience. And so we expect developers to implement this back channel and asynchronous state update back to us. It works regardless of whether you use an utterance and say, Alexa, turn on the living room lights, or also if you use the Alexa companion app. It all works the same way. Obviously, the companion app doesn't go through this speech section of our APIs. So the smart home skill really has 3 distinct parts. The first is discovery. Discovery is where we call the partner skill and we say, do you have any devices for this particular customer? We get an API response back from the skill. It is a discovery response, and that discovery response essentially says, here's the devices that the customer owns, here's the living room light, here's that light's capabilities. Does that light have the ability to control color? Not all bulbs do. Is it a dimmable bulb? Those capabilities will come back in the discovery response. Once we have the capabilities of the device, we now can control it, and that's the second component. So sending those directives down to turn lights on, set the brightness, lock the door, unlock the door, those are all control directives. And then finally, the ability to know the state of the device at any given point in time to be able to show that to a customer to make it queryable, that's all the state components. So those are the 3 different components of the smart home APIs. We've implemented smart home APIs for specific devices. I've already mentioned them, thermostats, locks, lights, smart plugs. We have very specific APIs that control those specific devices. We call those specialized APIs because they are tuned for those particular devices. And there's a reason we did that, and that's because that's where customers are. When customers started to adopt smart home, they went out and bought Philips light bulbs, and they bought the Nest thermostats. They bought a small set of devices like lights, locks, plugs, and thermostats. And so what we did in trying to adapt that market is we tried to build the most natural way to interact with those devices, as well as very specialized APIs. And so with the Smart Home Skill Kit today, you control these specific devices, and you can customers can interact with them very, very naturally. You see, though, in this graph, there's a long tail of devices that we don't have specialized support for. So what about them? What if you want to control one of those devices? How does a developer get their device to be controlled by Alexa? Today, that's via custom voice models. And this is basically just a normal Alexa skill. So with a custom skill, you define your voice model, and you define the control actions that happen behind the scenes. And so for a smart device like iRobot, where we don't have a robot vacuum skill, that's how they've enabled voice control with Alexa, and that's actually a very, very popular device and skill. You may also have a smart device that really does fit one of our specialized APIs, but the full capabilities of your device are not matched by that API. The ecobee thermostat's a really good example. So ecobee is a great thermostat, and they've implemented the thermostat skill. And so now you can say, Alexa, set the temperature to 72 degrees, or turn on the heat. ecobee, though, they wanted to be able to have voice control of, for example, their schedule. They wanted to be able to say, resume the schedule, pause the schedule, or turn on vacation mode. Well, those were not part of the thermostat specialized API. So what ecobee did is they built their ecobee Plus skill. That's that second skill you see there. And that enables them to they've built voice models for controlling the schedule and controlling vacation mode. There's a couple problems with it. The first is there's two skills, and the customer has to know that there are two skills, and they have to know why they need both skills. The second is when you interact with a custom skill, you have to say ask. So you have to say, Alexa, ask ecobee to resume the schedule. It's a little bit unnatural for customers. And finally, there's a higher burden on developers in that any localization, any tuning of the language model has to be done by you. So that's kind of where things are today. So we wanted to fix some of the problems that I've already kind of hinted at. The first is the specialized APIs. They're great. One way to think about them is those Lego kits that you can buy in the toy store. I'm a big Star Wars fan. I love building the X-Wing fighter, the Millennium Falcon, the Death Star. You buy that kit, you can build that thing. I can't build a Millennium Falcon with the X-Wing fighter kit and vice versa. So those Lego kits are great, but I wanted to be able to enable developers to be even more creative. I want to give you a box of Legos and have you figure out what you want to do. So we wanted to provide some more generalized APIs that can control broader sets of devices. And the second thing is that friction with those custom skills, we wanted to make that go away, both from a voice perspective as well as from a developer perspective. And so there's 3 integration options that we're presenting today. These are all in developer preview. The specialized capabilities, they're not going anywhere. If you want to build an X-Wing fighter, you should keep building an X-Wing fighter. If you've got a thermostat, use the thermostat skill. It's great. It provides the best way for customers to interact with a thermostat, and it's the cleanest API surface for you to model your capabilities. If you don't match, if your device doesn't match one of those specialized capabilities, next check out the primitive capabilities, and that's what we're going to be talking about a lot today. The primitive capabilities are those general Lego blocks that you can build whatever you want. We've got 3 new APIs, toggle, mode, and range. And we're going to talk about those in subsequent slides, and Mark is going to go through them in a lot of details. And then finally, we've made some improvements to the custom voice model such that you only need one skill, and over time, the need to say ask will go away. So talking about our primitive capabilities, the first is toggle. The toggle is anything that you can turn on or off. Now, we already have a power controller, and a power controller is also turns things on and off, but you can only have one on a device, and it's meant to be the power for the device. But if you think about all the devices that you have in your house and the things that can be turned on and off within those devices, there's lots and lots of them. There's the steamer on the dryer. There's the oven light or the child lock on the oven. And I'll talk about this throughout my next couple slides. As a thought experiment, we thought about how we would model a guitar amplifier. So guitar amplifiers have, for example, an overdrive mode. So you could model the overdrive with a toggle. And the interaction, the voice interaction with that is pretty simple. Alexa, turn on overdrive on the amp. The next one is mode. Mode is for anything that has multiple settings or presets with it. And so simplest example here is the one that you see, which is like a washer or a dryer, where you can say set the washer to delicates or set it to whites. And it has, the mode controller supports both ordered and unordered. So if you wanted to, for example, use fan speeds, high, medium, and low, and name them, you could say set the fan speed to high, or Alexa, decrease the fan speed. To go back to our guitar amplifier, mode would be for sound presets. If you have different kinds of sounds that already preset up that gets you to a specific characteristic of sound, you could use a mode controller for that. And then the final primitive capability is range. Range is just any numeric value. Again, you have lots of these in your house. Think about anything that has a temperature in your oven, your refrigerator, or range, your iron. Volume, fan speeds, and if you wanted to use numeric fan speeds, if that's how you wanted your customers to interact with your skill, you could use a range. And so Alexa, set the oven to 300 degrees would be a natural utterance you could use with a range controller. And so if you think about toggle, mode, and range, and you think about the ways that you interact with the physical world in your house, it's going to be hard to find, we think, something that can't be modeled using toggle mode, and range. And so we're pretty excited about just these kind of generic Lego building blocks. We said that custom utterances were a little bit difficult for both developers and customers, and so we're making a couple steps to make that better. The first is the capability to have multiple models on a given skill. So today, when you add a skill, you have to select the model for that skill, which it might be smart home or video or custom. That's gone. You can add now multiple models to your skill. We're calling that multi-capability skills. And so ecobee no longer will need to have ecobee and ecobee plus. It'll just be the ecobee skill, and it'll have all of those capabilities with it. And that'll be a lot easier for customers to find. And then we're also announcing name-free skill invocation. So this is the ability, instead of saying, Alexa, ask ecobee to resume the schedule, you could just say, Alexa, resume the schedule. So both of those are also in developer preview and will launch soon. Now, one thing I want to point out, the primitive capabilities have relatively simple utterances: turn on, turn off, set to, that sort of thing, increase, decrease. You may find that your particular branding requires something a little bit more custom, and that's where you still probably want to be able to leverage custom skills alongside the generalized capabilities. One example would be a grill, where you want to be able to say, Alexa, turn on the grill. We've got that covered. That's handled by the power controller. You might want to say, set the burner to high. You could model that through a range or a mode. But maybe you want to be able to say, Alexa, fire up the grill. Well, that's not something that our voice model supports. And so in order to do that, you could add the custom model to your skill, put in that custom utterance of fire up, and then everything would happen, and your brand would be kind of reflected in the skill alongside all of these natural capabilities. All right, I'm now going to turn it over to Mark. Mark's going to come up and show you how this works in more detail.
1, 2. All right. Hey, everybody. Thanks for coming to our breakout. My name's Mark Aiken. I'm a principal engineer and I work on Alexa Smart Home. And I'm going to walk you through some of the details of how this actually works, right? We're really excited to give you these Lego blocks. We expect that that'll let you integrate a whole bunch of new device types with Alexa with less effort. I'm going to show you some detail about how you can actually leverage that. So to make it tangible, we're going to use a running example. We're going to use this device as an example. And I want you to imagine, because this is just the control panel, this is a Moen shower. It's a really high-end model. And this is the control panel for the shower. So obviously you're not looking at the actual shower outlets. These are just the controls. And what I'm going to show you is today in the smart home APIs, we don't have a shower controller, right? Those specialized capabilities that we've built for specific device types haven't gotten to shower yet. But I'm going to show you how if this were your device to integrate with Alexa, you could use the new general purpose, the primitive APIs, to hook up all the device functions. You're not reliant on us to have supplied a shower controller. And the kicker is you can integrate all these functions and get an Alexa-supplied voice model. You don't actually have to write the whole voice model for this device anymore. I'll show you how you can accomplish that. Let's take a look at what we're actually going to be hooking up. So this control panel will get built into the wall, right? You see a big power button for turning the whole thing on and off. This device lets you fiddle with the water temperature, which you see on that screen, right? Apparently the water coming out of this thing at the moment is 100 degrees. So the red up and the blue down arrow control that. This particular model has 2 shower outlets. There's an overhead one and a handheld one, and there are buttons for turning each of those on and off individually. And then there's a 1 button and a 2 button. The customer in the Moen application can store combinations of settings under either 1 or 2, right? So the idea is you jam number 1, and it does all the combination of number 1 settings. Okay. Rick mentioned just a few minutes ago kind of the 3 basic functions that a smart home skill has to implement. That's discovery, control, and state. We're going to be spending a lot of time talking about discovery, because that's the step where you describe devices to Alexa. You say what's available to use and what each of those devices can do. Discovery is the step that happens first, right after your skill is installed. So once the customer's picked your skill, installed it, there's an account linking step where we get some OAuth credentials. Then the first thing that happens is Alexa sends you a discovery request, which is just a JSON blob. You answer with a bigger JSON blob, which is the discovery response. You enumerate the devices, we call them endpoints, and each endpoint has 1 or more capabilities, which are things that Alexa can understand and control about that endpoint. Every event or directive in Alexa has 2 parts. It has a header and a payload. Header's not super exciting. This is what one looks like. This would be your header if you were sending back a discovery response. And as you can see, it basically says, I am a discovery response. The event has a unique ID. The payload is more interesting. So here we're starting to build up an example of what the Moen skill might return to Alexa to describe this shower device. So the first thing that you need to convey is that the shower exists. All right? So in the payload, there's an array of endpoints, and so we're going to start building up the one for the shower. These are all global attributes of endpoints. They're pretty basic. The endpoint ID gives it a unique programmatic identifier. There's a friendly name, which is the natural language name that the customer can use to refer to this device. So that's Smart Shower. You can give us a longer description. We show that in the GUI. You can tell us the manufacturer. That's Moen. There are these display categories. We have a few sort of groups predefined in the GUI. There isn't one for shower. It's fine. You can just say other. And then right there at the bottom, you can see we start to define the list of capabilities. And that's kind of where all the interesting action is. Just to demonstrate, telling Alexa that the shower exists, there's 1 capability you must implement. It's the Alexa interface. That defines basic events and directives. All right. So with just this, if your skill returned just what I've shown you, you would tell Alexa that there exists this device. It's called Smart Shower. All right, so that's good, but we can't actually do anything with it yet. So let's start hooking up the different device functions. We'll start out easy. The first most basic one is just turn the whole thing on and off. Since we're getting warmed up, we're not actually going to use one of the primitive APIs just yet. This is one of the pre-existing, that's been around for a while, specialized API. It's the simplest one of them. It's really for just hooking up basic power control to the device. And so Power Controller gives you the experience like Alexa start the shower, Alexa turn on the shower. Here's what it looks like to use that. So here we're actually hooking up that capability so that you get the Alexa-supplied voice experience, and you don't have to build it yourself. This is in the array of capabilities. So here we're adding a capability to the shower endpoint. So we're sort of within that JSON document that you return from your skill. Adding a capability is pretty straightforward. You say, I want to use an Alexa interface, specifically the power controller. Current version of that interface is 3. And every interface defines methods, basically operations, that you need to support, and a number of available state properties which you don't have to support, but it works an awful lot better if you do. So in this particular case, we're saying, yes, this device does in fact have a reportable power state property. The flags say that the device isn't going to push those proactively to Alexa. We're a little sad about that. As Rick mentioned, please do implement that functionality if you can. But it says that Alexa can ask for the device's state. So in this particular case, you couldn't set up a routine that says, whenever I turn on the shower, like start playing Jimi Hendrix or something. But you could ask Alexa, is the shower on? She would query the device and let you know. OK. That's all it took to hook up power. That's it. I'm moving on to the next one now. Right? So just by describing your device and using the power controller capability, you got start the shower, turn on the shower, turn off the shower, stop the shower, all of our variant forms that we've built for you. You did not have to lift a finger to build any of those utterances or example, or any of the intents or example utterances, or do any slot design, nothing. OK, let's try one that's a little bit harder. For the next thing, let's hook up the individual controls. I mentioned that this thing has 2 outlets, right? There's sort of one mounted above the person's head, and then there's this handheld one that's on a hose. All right. And each of those outlets can be individually controlled. So for this, we are going to use one of our new primitive, the building block APIs. We're going to use toggle controller. So here comes one of the first wrinkles. Until now, we had these opinionated APIs, specialized APIs, and you could only use one of each kind of controller on an endpoint. And that was because until now, it didn't really make any sense to have more than one. For example, if you've got the power controller, it's for turning the device on and off. It doesn't mean a lot to say, I've got an endpoint, here's what you need to know about it. It can be turned on and off, and then say, another separate thing you need to know about it, I can also be turned on or off, right? Like, it doesn't make any sense. For toggle, though, toggle's a generic building block. We expect that for a complicated device like this, you may need to use more than one instance of the same primitive controller. For this one, we need to use 2 toggles, one for the upper shower, one for the lower shower. So we've added a mechanism that didn't exist before. Here we're adding the toggle controller to the discovery response. There's a new field, which is this instance identifier. This does pretty much what you think it does, right? You can assign, you can make up a unique identifier for this instance of the toggle controller. Whenever we communicate with your skill, we'll specify the instance of toggle controller that we mean, so you can have more than one. The rest of this should be starting to look familiar. The toggle controller comes with a single state property. It's called toggle state. And this is saying, yes, that's supported. No, I won't tell you about it, but you can ask. All right. That's all it takes to hook up the individual controls for the overhead and the hand shower. You still haven't done any custom voice development. You haven't had to do anything about the voice model. You get turn on the overhead shower, start the overhead shower, turn on the handheld shower, turn it off. All those utterances are supported just by opting into the toggle controller. Actually, I lied. You need to give some additional configuration to the toggle controller to let us know what this setting is actually called, like how customers should refer to this individual setting on the device, right? There's one toggle for the overhead, and there's one toggle for the handheld shower. So this is also a new thing. The primitive capabilities need a little bit more configuration than the really specialized ones. And one thing that they need is that natural language terminology. So we call this the friendly name, right? Before a whole endpoint has a friendly name, this device's friendly name is Smart Shower. But now you can give the individual capabilities friendly names as well. You can have more than one. We call those synonyms. The first one's a little bit special. We'll show it in the GUI, right? So that's the one that you want to be premier, but you can give us any number of sort of aliases, and all of those will work via voice. Here's what it looks like to configure those in the discovery response. So you give this capability resources block, right? And one of the aspects of configuration you can specify in there is the friendly names. Like I mentioned, you can have as many as you want. In this particular case, we're saying that the friendly name for like the toggle 1 controller is overhead shower, and there's an alias, you could also call it outlet A. Why not? There could be as many of these as you want. Okay, so now I'm no longer lying. Having specified the friendly name, you get utterances such as these, right? Turn on the overhead shower, turn off the overhead shower. Okay. We've talked only about what the discovery response looks like, how you describe this to Alexa. Let me say a couple words about, suppose a customer now says one of those things, right? They say, turn on the overhead shower. What happens? Well, we send you a control directive. This is the third pillar of the functionality of smart home skills that Rick told you about before. The turn on directive is very straightforward. You could probably sort of guess all the things cold that are in it. The header says, I am a turn on directive, specifically one that's meant for a toggle controller. We give you that instance identifier. That's a programmatic identifier that you guys made up to distinguish this specific toggle controller, so you get it back so you know which one we're talking about. It's not shown here, it's in the commented out section, but in the endpoint block, you also, of course, get the endpoint identifier that tells you that we're actually sending this to the shower device as opposed to some other device you might have revealed. There's no payload for turn on because turn on is just intended to do what it says. Okay. The point of this, though, isn't to walk you through integrating a shower. Like, I'm not sure if anybody in the room is going to connect up a shower. Maybe you will. Like, if you do, that's great. But the point is to get you thinking about all of the device functions that your products may have that you could integrate with Alexa and get this Alexa-supplied voice experience, essentially for free, by using a toggle controller. So as Rick mentioned before, any device that has individual features that can be individually turned on and off, right? Child lock on an oven, the DMZ on your router, the extra spin on the washer, any device function like that, you can tell us the friendly name, you can tell us that you're using a toggle controller, and you'll get the basic voice experience simply supplied for you. In the past, you would have had to create custom intents, example utterances, localization would have been on you, right? You'd need to do all that work just to get to a basic voice experience for these basic features. All right, I told you to hook these all up. Let's start blowing through the other ones. The other feature of this device is that you can customize the water temperature. So let's get that working. This device is pretty fancy, right? It can tell you the water temperature like in terms of specific degrees. So we're gonna use a range controller, like Rick mentioned, which is appropriate for device settings that are basically a number within a range. So let's go ahead and use that. This should start to look familiar. You say, I want to use a range controller. Same basic setup. The range controller comes with a range value property, and we're saying, yep, I support that. You can ask for it, but I'm not going to tell you about it. The range controller needs a couple other bits of configuration. It needs you to tell us the minimum legal value and the maximum legal value, and you've got to tell us that, because otherwise we might try to drive any legal value to you. Other knobs and switches, you can tell us the precision that you accept. For example, an even fancier shower maybe could hit half degrees or quarter degrees. The default step is 1, but you can set it to whatever you want. And then optionally, to make sure we get the voice experience right, you can tell us what units your device is actually expecting. And that lets us catch things like if somebody says, set the shower to 72 meters. Doesn't really mean anything. For our particular shower, it's expecting degrees, right? It's expecting customers to say degrees or degrees Fahrenheit. This configuration block is how you set the different configuration knobs and switches for the range controller. Okay, so with just this, you get such things as Alexa, set the water temperature to 83 degrees. So that's good, right? And it sort of shows off the detailed control of this particular device. It's also not very human, right? It's kind of robotic. I don't know my preferred water temperature to like exact degrees Fahrenheit. So I suppose you want to sort of round this out with something a little bit more human, right? You want to let customers say, set the shower to warm, or hot, or lukewarm, or cool, sort of like basic common sense terminology like that. You can even get that with an Alexa supplied voice model, right? Like at no point here have we defined a custom voice model. You can define presets on a range controller where you identify specific values to us and then give us the friendly name terminology that goes with those, like warm. It's pretty easy. It looks like this. This is in the configuration block for the range controller. You can give us any number of presets. This one says that apparently 103 degrees is warm. So if you ask the Moen shower, set the water temperature to warm, you'll get exactly 103 degrees Fahrenheit. Seems reasonable. Oh, sorry, it's hot, not warm. 96 degrees below it is warm. So with the preset that I just showed, the hot preset, in fact, if the customer says either, Alexa, set the water temperature to 103 degrees, or set the water temperature to hot, you'll actually get the same control directive. The control directive for the range controller is a set range value. This is when we're driving a specific value to you. As you might expect, in the payload, you get the specific value that you should set your controller to. And as I mentioned, if the customer had said hot or 103, you would get this exact same directive. Okay? One more embellishment for the water temperature control. Suppose you want to let customers bump it up and down, right? After all, that's the functionality of the arrow. You make it a little bit warmer, make it a little bit cooler. You can also get that functionality for free with a range controller. In fact, you don't have to supply any additional configuration to get that voice model. We'll simply light it up for you. So just by having configured the range controller the way I showed, customers can in fact say, increase the water temperature, decrease the water temperature, or even decrease the water temperature by 5 degrees. You'll get a different directive in that case. You'll get an AdjustRangeValue directive, and the payload of that directive gives you the delta. One little nuance, you get the delta in our example case decreased by 5 degrees, you get -5. And you get this hint in case it matters to you, because you could do like easing or smoothing around the edges for customers that just say increase or decrease. Maybe you have some business logic about what the sensible behavior in that case is. You get this flag that tells you whether the customer was explicit about the delta, or if we just set +1 or -1 because that was the default behavior. And so you can hook up even nicer business logic to that if you want. Okay. We're done integrating the water temperature control. And again, this isn't a tutorial on hooking up showers. The point is to get you thinking about, how many device functions for devices that you guys manufacture or care about or are trying to integrate with Alexa could you model with basically integer, right? Temperature, speed, volume, brightness, our intention is that all of those basic settings for devices, which we haven't guessed or covered entirely, you can now hook them up by telling us their name, the valid range, step, units, and we deliver you like a pre-made voice experience so that you don't have to build it yourself. Okay, there's one more feature to go. There are these preset buttons. We're going to use them to show mode controller, which is our remaining primitive API. So remember, you hit one, there's some stored preset of combination of settings that the customer set up, get those combination of settings. Mode controller looks like the other one. Comes with a single property called mode. This should look familiar. The configuration for mode controller, as you might imagine, means you have to tell us what the modes are. They each have a programmatic identifier, which is their value, like preset 1 that you say here. And then, as per usual, you have to tell us the friendly names. How does the customer refer to that particular mode? I want to draw your attention to something that might not be immediately obvious on this slide. Here we're showing that the preset 1 button, the customer can refer to as post-workout shower. So I want to emphasize that when you're returning a discovery response from your smart home skill, you're returning the devices for a particular customer, and you're describing that particular customer's devices. So the Moen shower doesn't ship as a product, right, with only post-workout shower as the name for preset 1. This reflects that the Moen customer, by some other channel, probably the Moen app, went and assigned a friendly name that they preferred, post-workout shower, right, to the preset 1 button. And here Moen's passing that through to us. I just wanted to mention it because I didn't want you to get the idea that all of this discovery response is on a per device class basis. It can be personalized to your particular customer. So you can pass through settings that reflect how the customer set up their device. So just with that, now the customer can say, Alexa, turn on post-workout shower. You're kind of getting the pattern here, right? If they do that, we will send you a set mode directive. As you might imagine, the payload says your programmatic identifier for one of the modes that you called out to us. And again, the point is, think about what you can do with mode controller. Rick mentioned an application of mode controller earlier that might also not be immediately obvious. So you can use mode controller for like cycles on a washer, right, where there's just some set of alternatives. There's delicates and whites and wool. That's fine. But you can also use it for a setting that you might think of as more of a range, right, but that just has a few stops. So most fans can't control their speed to within exact RPM, right? So it might be a little bit of a stretch to use a range controller for that. Simple fan might have off, low, medium, high. Things like that, where there are simply named stops, there's no numeric value involved, are appropriate to build with Mode Controller. Mode Controller has this extra little feature built into it where you can pass the ordered flag as true. And if you do, you're letting us know that it means something for the customer to say, increase the fan speed, decrease the fan speed. And if they do, we'll send you a directive that's for that. Very similar to the Delta directive that we saw earlier for the Range Controller, which is adjust mode. As it turns out, the payload that you'll get today for adjust mode is always either +1 or -1 to reflect, please increase or please decrease. Okay. We've integrated all of the shower's functionality. And again, I want to emphasize that all of the voice utterances that you saw getting enabled through all this, you didn't have to build, right? Turn on, turn off, I want the overhead shower, I want the handheld shower, give me my post-workout shower, turn the whole thing off, right? All of that are sort of templated voice experiences that we've built within Alexa that you can simply activate by using these capabilities. I want to talk about a couple additional mechanisms that come with them, because using these at scale mean that you face certain challenges that we've also tried to think ahead and help you with. So the first one is, if you think about it, I've said, hey, you don't have to build your own voice experience, but you do need to supply the friendly names for all these settings, right? There's whites, wool, delicates, whatever the modes are. Alexa runs in several languages. You need to be ready to give language-appropriate terminology for each of your settings during the discovery phase. All right. We tried to make that somewhat less of a burden. Along with the primitive launch, we've defined a set of common terminology that we think will be useful for common device settings. Your device's settings might not all be in there, but if there is an Alexa predefined for your device's setting, like temperature, for example, is super common, you can use that, and then you don't have to worry about localization. So if you use one of our preset assets, you get a sensible set, or a set that we think is sensible, of aliases, synonyms in all supported Alexa languages for free. And the way you do that is all the examples that you saw of passing natural language strings so far had type text, and they were literal strings. You can instead say type asset and pass the identifier for one of our predefines. And then you don't have to actually worry about the localization. In case it wasn't obvious, you can also use assets for the individual modes, for example, individual settings or presets. So here's an example from the Range-Controller. Remember when we made 103 degrees mean hot? We actually have a predefined for hot, since that's a common piece of terminology for smart home devices. And you can use the asset when you're setting up the label, the name for a preset. To go in the complete opposite direction for just a moment, if you do have specialized terminology, it's branded, you have special names for your device's features that aren't super common, or you have presets like Turbo Blast or something that we didn't choose. If you think about it some more, if you have a bunch of synonyms for those settings, right? So far, the mode that we've shown is that you would pass all of those synonyms as a big array in the discovery response. And the discovery response is per device, per customer, right? The discovery response could get pretty bulky. We've also made a mechanism where, kind of similar to the music catalog, there are a couple other examples of this in Alexa, you can sideload your catalog of language assets so that you're not passing all of that bulk of synonyms back and forth and having to redrive discovery messages when the customer changes language, all of that. So the catalog is just a giant JSON file. You can upload it through the developer console, and it looks like this. It's just a giant list of your assets. Every asset has a unique identifier, so this is the preset 1 asset, and you can give us a map of what the human language terminology is and any number of synonyms on a locale by locale basis. So here there's the English string preset 1, and there's a continental French version as well. And so you can cover all the languages this way. All right. The last thing that I haven't talked about, in case you noticed, was, remember we set out to improve two things. We wanted to reduce the effort and the lifting that you have to do to hook up particular device functions. And then we also wanted to lower the friction when you do choose to build a custom voice experience to round that out. There's one mechanism that you should know about in order to get the best seamless voice experience when you try to supplement the Alexa-built primitives voice experience with your own operations. Might not be immediately obvious, but in the discovery response, you can give back multiple devices. For us to be able to get rid of the tell ecobee or tell Moen, Alexa needs to know which of your custom intents actually make sense against which of your endpoints. So we need to know that if you reveal like a shower to us and a toy car to us, that it means something for the customer to say, drive forward to the car, but it doesn't mean anything to say drive forward to the shower. The mechanism for this is custom intent. You simply tell us, you simply name the custom intents that your skill implements that make sense for a particular endpoint. In this example, Moen has a customized shower name intent, which is probably for like setting a new friendly name for the shower. It's not something we support out of the box. And they have some custom utterances for turn on and turn off. So maybe it's, let's get in the shower and kill the shower. We need to know that those utterances can apply to the shower so that we can do the best job of disambiguating when the customer says, kill the shower. All right, that's all the flourishes that I've got for you. There are other mechanisms that I didn't mention, but we covered quite a lot of them. So just to summarize, we set out with a novel device with a bunch of functions that Amazon had not built and supplied a specialized API for. We haven't gotten around to shower yet. But undeterred, right, we chose the primitive APIs that were suitable for each of the device's functions and hooked up each of those functions in that way. And we wound up with a sensible, basic, functional voice experience for all the features of this device without ever having to actually get into designing a custom voice model. We even got to skip some of the work of localization by leveraging presets for a common terminology that Alexa defines. One more point, I promise this is the last one. You may also not have noticed that a lot of the utterance examples that I gave you were not, in a strict engineering sense, completely unambiguous. Right? A completely unambiguous utterance for the shower might be to say, Alexa, set the mode of the shower to morning shower, which is completely unnatural, right? Or for a washer, you might say, set the wash cycle of the washer to delicates. Nobody wants to say that. As part of the primitives voice model, we do our best to infer what the customer is talking about based on the names that they do use, right? So if you say, turn on the guest Wi-Fi, only the router has a guest Wi-Fi setting. We understand that you're saying turn on the guest Wi-Fi on the router. All right. Lest you think that this Moen shower thing is just a mythical creation, we have a very brief demo video. It's just 2 minutes long. In one of our flagship buildings in Seattle, we have the Smart Home Lab. Smart Home Lab is actually an entire small apartment that is populated with all sorts of different smart home devices. We do press events there, and we can sort of like tear it down and rearrange it to test out different devices. The apartment has a bathroom, and the bathroom has a shower. And the shower works. Not sure anyone's ever taken a shower in it. But we built this Moen device into the lab bathroom shower, and I just wanted to quickly demonstrate that this is, in fact, how we got the voice model for that device working, and to sort of let you see that in action with an actual Alexa device.
Alexa, start the shower.
Okay.
Alexa, set the temperature on shower to 108 degrees.
Okay.
Alexa, decrease the shower temperature by 8 degrees.
Okay.
Alexa, turn on right body spray.
Okay.
Alexa, turn off the shower.
Okay.
Alexa, turn on workout shower.
Okay.
turn off shower.
Okay.
Alexa, turn on morning shower.
Okay.
Alexa, turn off shower.
Okay.
Alexa, good morning.
At the moment, traffic on your commute looks pretty clear. The fastest route takes about 7 minutes via First Avenue and Blanchard Street. Right now in Seattle, it's 53 degrees Fahrenheit with cloudy skies. Tonight's forecast has mostly clear skies with a low of 41 degrees.
Alexa, turn off shower.
Okay.
Okay, so when the team got a hold of that shower, I made a very strong case that they shouldn't put it in the home lab in that building. They should put it in my bathroom because I would like to be a beta tester of that thing. You saw that in the video, that was an upgraded version of the Moen shower where it had 4 outlets, not the 2 that we had. So I think that thing would have been pleasant to have, but alas, the team denied my request. Another interesting thing, by the way, we didn't talk a lot about it, but routines is really where smart home automation really comes into its own. Now that I've been automating my own personal house, I've got a bunch of different routines set up to like turn lights on and off. And for example, when we say Alexa movie time, everything gets ready for my movie night where I can get the lights dimmed and I get the Fire TV turned on and everything else. Every capability of a primitive device will also be able to participate in routines. And that particular routine that you saw, I think it was Good Morning. It was Good Morning, right? So with Good Morning, they started a particular preset, and then they played the traffic and the weather. So that'll be available to everybody who implements a primitive capability. As I mentioned, we're in developer preview right now. We've been working with Moen and a couple of others to really fine-tune what it means for these capabilities to work and be natural to live with. All of the documentation for the primitives is available now at this link, and there's a place on that page where you can sign up to get notified when we're accepting more developers into the preview or when we go live. And so I definitely encourage you to check that out. Like I said, all the stuff that Mark talked about and much more is documented there in that link. So please hit that up. Couple of related breakouts that you might want to check out. Alexa is, I think, a very developer-friendly ecosystem. We've talked a lot about smart home development. Here you can talk about integrating voice into your product as well. That's what that first session is. And then the second session is more about games and Alexa skills and seeing what you can do to integrate those two things. So check those out if you're interested later today and tomorrow. That's our talk. Thanks for coming out. We're really excited to see what you guys are going to build with these new capabilities. Customers are really enjoying smart home, and the more devices we have to give them, I think the happier they'll be. Thanks a lot. Please don't forget to fill out a survey.